Statistics. Graphical representation of data. Bar graph, subdivided bar diagram, percentage bar diagram, histogram, frequency polygon, mean and median of data. Graphical representation of data. The graphical representation of data is easier to understand than actual data. We will study the following graphical representation in this section. Bar graph. Histograms of uniform width and of varying width. Frequency polygons. Bar graph. Bar graph is a pictorial representation of data, in which usually bars of uniform width are drawn with equal spacing between them on x-axis. The bar heights vary with the values of variables shown on y-axis. This graph presenting data of 40 students and months of their birth. If we have to find the number of students born in the month of November, we can easily access from graph that 4 students were born in the month of November. Subdivided bar diagram. Suppose we have a table showing data of yearly yields of grains of a farmer. We have to represent yearly data in a single bar. For that, draw XY axis, mark year on x-axis, keeping equal gaps. Choose proper scale on y-axis for total yield in quintals. Select shaded region for jawar and unshaded region for wheat. Now consider total yield in year 2004. It is 60 quintals. Draw a bar for 60 quintals. Now, out of 60 quintals, 25 quintals is jawar. Hence, shade the portion of bar from 0 to 25 for jawar, and remaining unshaded portion of bar will represent wheat in quintals. In this way, we can represent data of each year in the graph. In such a way, representing 2 or more quantities through single bar is called subdivided bar diagram. Percentage bar diagram. We have another way to represent data by bar diagram. Percentage bar diagram. In this graph, we convert given data in percentage form and represent it by shaded region in a bar. In this bar diagram, the height of bars are equal. For example, in a shown table, number of students passed out of 60 in division A are 54. Therefore, percentage of student passed is 90%. Same way, we can find percentage of students passed in division B, percentage of students passed in division C, and percentage of students passed in division D, and complete the graph. Histogram. This is a form of representation like the bar graph, but it is used for continuous class intervals or say for groups and no space between 2 bars. This is the frequency distribution table representing the weight of 36 students of a class. Let us represent this data graphically. We represent weights on x-axis on a suitable scale, that is 1 centimeter is equal to 5 kg. Since first class interval starting from 30.5 to 35.5 and not from 0, we show it by marking a kink or the break on the x-axis. On y-axis, we represent number of students, that is frequency. Since maximum frequency is 15, we choose a scale 1 centimeter is equal to 2 students and mark up to 16 on y-axis. Now, for first class interval 30.5 to 35.5, number of students are 9. The middle line of 8 and 10 represents 9. Draw bar up to the height for a class interval. Similar way, draw other bar for class intervals and respective frequencies. This resultant graph appears like a solid figure. This is called a histogram. Frequency polygon. To understand frequency polygon, let us take a histogram of above example. Let us join the midpoints of the upper side of each bar by line and name midpoints B, C, D, E, F and G respectively. To complete the polygon, we assume that there is a class interval before first class interval and last class interval and mark midpoints for them as A and H. A, B, C, D, E, F, G, H is a frequency polygon for the data which was given for histogram 2. Frequency polygon can also be drawn independently without drawing histograms. For this, we require the midpoints of the class intervals used in the data. These midpoints of the class intervals are called class marks. We can find class marks as class mark is equal to upper limit plus lower limit divided by 2. Let us draw frequency polygon for the table. In the table, class intervals of height are given for numbers of students. Since we want to draw a frequency polygon without a histogram, let us find the class mark for each class interval. Class mark for first class interval is 150 plus 140 divided by 2 is equal to 145. Similar way, we can find class marks for other class intervals of the table. Let us draw a frequency polygon plotting the class marks along the x-axis and the frequencies along the y-axis. Mark point B for frequency 5 and class mark 145. Similar way, mark point C, D, E, F and G for each frequency and its class mark. Join points by line segments. We should not forget to plot the point corresponding to the class mark of the class interval 130 to 140 and 200 to 210 on x-axis. So the resultant frequency polygon will be A, B, C, D, E, F, G, H. We have seen mean as a division of sum of observations divided by numbers of observations. Mean is denoted by symbol x bar. Mathematically, mean is represented by summation of all xi for I is equal to 1 to n divided by n, where xi are observations from 1 to n and n is number of observations. Median. Median is the middlemost value of the observations. If n numbers of observations are taken and n is odd, the middlemost value will be n plus 1 by 2th observation. And if n is even, the middlemost value of the observations will be the mean of n by 2th and n by 2 plus 1th observations. Summary. In this subtopic, we have seen bar graph, subdivided bar diagram, percentage bar diagram, histogram, frequency polygon, and mean and median of data. That is all in this topic. Maths is fun, so keep learning.